Alright, so we've got some notes here to help you some more on section 3.2 through 3.4, so it's quite a bit of information. So these are just some examples that might help you. So the first one is a scaled problem. On a map, the scale is given as 1 inch equals 10 miles, meaning that 1 inch on the map corresponds to 10 miles of actual traveling distance. If two towns are 3.6 inches apart, how far are they actually? So we can set up a proportion. 1 inch over 10 miles equals 3.6 inches over how many miles? And we can cross multiply to get 36 miles. So here's another one. We have a scale model. It's 1 to 72. So it's unitless, meaning it could depend on a bunch of things. Like if I wanted to convert to feet or if I wanted to convert to inches. So determine how many inches in the model corresponds to 1 foot in the actual. So we set it up with 12 inches over x feet, and we cross multiply and we get 6 feet. So it says always write the proportion with a smaller number on the bottom. So that's what we did in this case, and we're converting it using that. So another example. A boat has a top speed of 36 knots, which is nautical miles per hour. So looking up some conversions, 1 nautical mile equals 1.852 kilometers, and 1 mile equals 1.609344 kilometers. So if we set up our fractions, we've got 36 nautical miles times 1.852 kilometers per 1 nautical mile times 1 mile per 1.609344 kilometers. And if you'll notice again, like we've done before, the nautical miles cancels out, the kilometers cancels out, and so I'm left with miles. So I have 41.4 miles per hour. So notice on this one I had per hour here, and I'm looking for per hour here, so I don't have to worry about converting the time. Alright, so here's another example. So this gives you some conversions. So 8 bits in a computer is equal to 1 byte. 1 kilobyte is about 2 raised to the 10th power bytes. 1 megabyte is equal to 2 raised to the 20th power bytes. And 1 gigabyte is equal to 2 raised to the 30th power bytes, but in our book they use 10 raised to the 9th for a gigabyte conversion. So you will see that frequently where mathematically it's supposed to be 2 raised to the 30th power, but a lot of people will use the 10 to the 9th power as a little bit simpler conversion. So in this case, you have a 16 gigabyte tablet, and for a plain textbook, 1 byte typically corresponds to 1 character of data, and an average book consists of about 2,000 characters. So assume all 17 gigabytes are used for a plain textbook. How many pages of text can that tablet hold? So we're going to do some conversions. 17 gigabytes. And we have 10 to the 9th bytes over 1 gigabyte. And then we have 1 character over 1 byte. And we have 1 page equals 2,000 characters. Sorry, it's a little messy. So again, look at this. The gigabytes cancel out. The bytes cancel out. The characters cancel out. And all I'm left with pages. So I multiply the 17 times 10 to the 9th power. And then times the 1 times the 1, and then I'm going to divide by 2,000, and I end up with 8,500,000 pages. So my tablet, that's 17 gigabytes, can hold 8,500,000 pages. So the second part says, if a book typically has 500 pages, how many books can the tablet hold? So we have the 8 million pages. 1 book equals 500 pages. Pages cancel out. And I'm left with 17,000 books. Alright, so this next one was a little confusing at first. So it says calculate the scaled size, and size is in millimeters, to the distance, which is in meters, for a planet using 1 to 10 billion scale model solar system. So they gave you Neptune was 48,400 kilometers in diameter, and so that's talking about size, and it's 4,500 million kilometers, so that's talking about distance. So first we're going to convert our kilometers for the diameter to the millimeters so that we have the size. So we have the 48,400 kilometers, 1,000 meters per 1 kilometer, 1,000 centimeters per 1 meter, and 10 millimeters per 1 centimeter. So again, we've got our cancellations here. And so when I multiply all this across, I get, so we have 4,840,000,000 millimeters, and we want it on a billion scale. So I have to divide this by a billion, and I end up with 4.84 millimeters per billion. And then I'm going to do the same thing for the distance. So I have the 4,500 kilometers times 1,000 meters over 1 kilometer, but I want this to be in terms of meters. So I'm going to just multiply this across, and I get sometimes in my calculator a strange number. This is scientific notation. It means the same thing as 4.5 times 10 to the 12th. And then again, I need to divide by a billion, so I get 450 meters. So the scale would be 4.84 millimeters to 450 meters. All right, our next one. So determine the weight of a shoebox full of gold and the same shoebox full of lead. The shoebox has dimensions 12 inches by 6 inches by 5 inches. The density of gold is 19,300 kilograms per 1 cubic meter, and the density of lead is 11,340 kilograms per 1 cubic meter. So the first thing I have to do is convert, and this is supposed to be cubic inches, I'm sorry. Okay, so the first thing I have to do is convert my box size to cubic inches. So my box is 12 by 6 by 5, so length times width times height is 360 cubic inches. And now I'm going to take the information I have, I'm sorry, this was cubic meters and I'm converting it to cubic inches. Sorry. Okay, so I'm going to take the 19,300 kilograms per cubic meter, and I need to convert that to cubic inches. So that's my first calculation. So 1 meters cubed over 100 cubed centimeters cubed. So this is important. Since I'm cubing the meters, I have to cube the centimeters. So I can't just use 1 to 100. And then 2.54 cubic centimeters to 1 cubic inch. So again, my meters cancel out, my centimeters cancel out, and I'm going to be left with kilograms over inches cubed. So I multiply the numerators, multiply the denominators, and I end up with 0.316 kilograms per inches cubed. Well, my box is 360 cubic inches, so I multiply by my box, and I end up with 113.76 kilograms. So now I'm going to do the same thing with the 11,340 for the lead, and I'm going to set up the same proportions, and I end up with 0.186 kilograms per inches cubed times the 360, and I end up with 66.89 kilograms. So the box of gold will weigh more than the box of lead. So this next one, we have a Greenland ice sheet contains about 3 million cubic kilometers of ice. If it's completely melted, this ice would release about 2.7 million cubic kilometers of water, which would spread out over the Earth's approximate 337 million square kilometers of ocean surface. And how much would the sea level rise? So the first question is what you're trying to find. So I'm trying to figure out how many kilometers would the sea level rise if all this ice melted. And what unit of measurement are we going to use for our answer? We're going to use kilometers since everything else is written in terms of kilometers. And what two numbers given above would you use to find the answer? So the 337 million square kilometers and the 2.7 million cubic kilometers are the two numbers that I have to use. The first number that talks about the 3 million cubic kilometers of ice talks about basically everything that it has. What we need to worry about is the melting and the rise in the sea level. So if I take those two numbers and divide them, and I'm picking this number to put on top because then the kilometers will cancel out and I'll be left with 1 kilometer on top. So I end up with 0.008 kilometers. So the sea level would rise about 0.008 kilometers. Okay, and our last one, if an antihistamine is prescribed for a 100-pound person, the typical dose for a 100-pound person is 19 milligrams every 6 hours. So using this dose, how many 13.4 chewable tablets would I have to take in a week? So 19 milligrams every 6 hours would be 4 times a day, 7 days a week, would be 532 milligrams of medication in 1 week. So 19 milligrams, 4 times a day, 7 days a week is 532 milligrams per week. If I take 13.4 milligram tablets, that means I would have to take 39.7 tablets in order to get my dosage. So this medication also comes in a liquid form, and the concentration is 13.4 milligrams for every 8 milliliters. So how many milliliters would I have to take in a week? So 532 milligrams per 1 week, and 8 milliliters for 13.4 milligrams. Again, milligrams cancels out, and I would be left with 317.6 milliliters per week in order to get the correct dosage. Hope this helps.